Hello, Richard here, and welcome to part 3 of making a custom camera mount. This is the third one in this series and the last video of the series. And if you've been following along, you may remember that in part 1, we talked about what it was we wanted to do and how we were going to do it, and we came up with some designs, and we did a design in Fusion 360 of a camera mount. And then in part 2, we 3D printed it. So we sliced it up in Cura and we went through how we 3D printed it, and we ended up with these. The clamp and a knob to go on the end. Now in this part we're going to be making up a screw that goes into the knob, and that will go through here, through the clamp, to allow us to attach cameras and camera brackets and things like that. Now you may remember as well in part 1 I did say that we would be able to skip past any metalwork that's required. I know not everyone's into metalwork, not everyone's got one of these where they can make screws and things. So what I'm going to do, I'm going to walk you through making the screw using the lathe. But for those of you that don't have access to a lathe or just aren't into metalwork, if you skip ahead, I'll show you an alternative where you can actually just buy the bits you need off eBay or Amazon or wherever, and you don't have to do any metalwork at all, really, which is a bit of a bonus if you're not into that sort of thing. So what we're going to do next is we're going to make the screw, and before we do that, I'll just walk you over to the drawing and I'll show you what we're going to be doing. Okay, so here we've got a drawing of what we're going to be making, and I hope you can see this okay. It's all printed from our Fusion 360 design, and one of the problems I find with Fusion 360 is that when you do a drawing, it just does really skinny, thin lines, and the lines of the actual outline of the object are the same thickness as the dimension lines, so it makes it a bit hard to see. So I've gone over this in pencil a little bit, hopefully so that you can see what's going on. You can't beat a good old sort of old-fashioned bit of CAD sometimes, really. Anyway, this is what we're going to be making, if you can make head or tail of this. Probably easiest to look at the side profile, really, because basically this is the knob we're going to be using, and this is going to fit down onto this piece. Obviously this is scaled up a lot bigger. This is where the thread will be that goes into the camera bracket, and then this will basically screw through here and the knob will go on there. So hopefully that'll sort of orient you in the right direction. On the drawing here, this thread here is here and this flat is over here. So what we're going to do, we'll get a bit of brass up in the chuck. Now this is going to be 10 millimeters on its biggest diameter, and I've got some 12 millimeter diameter brass bar which we're going to use, so we don't have to turn too much down. And what I'm going to do, this wants to be 25 millimeters long, so I'm probably going to have about sort of 35 mil sticking out of the chuck, and we'll turn it down to 10 mil diameter over about a 30 mil length. So we've got the whole thing turned down to 10 millimeters. And what we're going to do, we're actually going to machine this end first. So once we've got this turned down to 10 millimeters, we're going to basically turn this diameter down to 5 mil diameter for 10 millimeters deep. And then when we've got that, we'll flip it around in the chuck this way. And then we can turn this end down to 6.35 millimeter diameter, which is our 1/4 inch UNC outside diameter of our thread. So we'll turn that down all the way, and then we'll undercut this bit down to, on the design we did 5 millimeters. I'm going to go to 4.8 just to give it a little extra undercutting. So we'll undercut this down to 4.8 mil, and then we can cut our thread, and then we're done with that. That's the plan. That's the drawings. Hopefully you've got a bit of an idea as to what we're going to be doing next. So next thing, over to the lathe, and we'll start cutting metal. So, as is often the case, the first thing we're going to do is face off the end of the brass bar. So we've got that in the chuck. First of all, let me just check I've got that tightened up. That's good. All right. So I'm just going to face the end off. And what I'm going to do for that is I'm just going to lock the lead screw, which will help to stop the work pushing back this way. And we'll just draw the compound slide back a little bit. And then we can touch off and just face off the edge there. See what we've got. Oh yeah, that's fine. All right, so like we said, we're going to turn this down to 10 millimeters diameter over its entire length. And we'll put a bit of a Sharpie on here, and then we can just put a scratch to show where we're going to cut up to. Okay, so that's our little target mark, and it doesn't have to be critical this, so we can just come in here, and as long as we're roughly there, we're going to have enough material to make sure that we're going to have our 25mm. Just double check that's the actual length we're going to be turning to before we part it off. So, all right, let's take it down to 10mm. Now, with the setup at the moment, I've got the lathe set up for screw cutting. So the feed rate of the lead screw is set for a screw pitch of 1.5mm. So that's going to be no good for power feeding. So we're just going to manually feed this across. Where it's brass, it's quite easily machining, and it won't take us too long to take us down to 10mm. So I'll optimistically grab a micrometer, because we'll be needing that in a moment, and let's start taking some metal off. About 9.9 something. Let's have a look. 9.94. That's fine. That's absolutely spot on for what we need. Now what we want is a 5mm diameter shaft on the end, 10mm deep. So we'll mark that off, and we'll get that cut as well. As far as I dare chance it before I measure, so let's hope we're still over 5. Yeah, 6.8, so still a little way to go. Okay, so that should be that. Let's just check what size we hit. 5, exactly, 5.0, nice. We'll just double check the depth as well. About 9.4, that'll do. This is only going to push up into the knob, so I'm not going to get too fussy over that. That'll be fine. And what I'm going to do is I'm going to grab a file, and we'll just just knock the sharp edges off here with a file. What we'll do now is we'll part it off at 25mm long, and then we'll flip it around and we'll work on the other end. So just clean the swarf off before we take the tool out. Swap over to the parting tool, and I'm just going to line the parting tool up on the face of the chuck jaws. Good a way as any, just to get it squarish, or as my youngest son would say, perfect-ish. That's pretty perfect-ish. Right. So next we want to get this set to 25mm in, near enough, and we'll measure in from there. 25mm, and I'm going to lock the feed again, make sure that's pushed up that way, and then we'll just set the depth with the compound slide. That's pretty close there. That's good. Okay, so we're just going to part that off. We'll turn the speed down, part it off, and then play hunt the part, and we can flip it round in the chuck and do the other end. Right, okay, so we'll take this and we'll flip it around and we'll put it quite close up in the chuck. I mean, we're going to end up working quite close, but that's not a big problem. When we're threading, we'll be a little way off. So we'll get that up there. I'm not too worried about marring the finish either. You know, the jaws might mar up that finish a little bit in there, but that's not too much of a big deal because it's just going to be inside the knob. And if it's a little bit rough, then it might even improve the grip. Well, that's my story anyway. All right, so let's go back to our normal tool. And as always, we'll face the edge off. Now I'm going to take it a little bit careful because we've only got 5mm stuck in the chuck, or rather 10mm stuck in the chuck of 5mm diameter. So it's not the strongest of things. So I'm not going to hog it too badly with this. But we'll just face off, and then we can take this down to our 6.35mm diameter up to 2mm from the end there to make a 2mm thick flange on that bit. Okay, nice. Right, so now what we need to do is to take this down to 6.35mm up to 2mm from the face of the chuck jaws. So we'll do our usual Sharpie thing. I'll be a little careful because I'm getting close to the jaws there, but there we go. So we'll measure ourselves in a bit, and how am I going to do this? It's tricky getting in really close on something like that, isn't it? Can I measure to the edge of the chuck jaws? That should probably do it. Let me set that to 2mm. I don't know if you can see that. So we set that caliper to 2mm, and then we can bring the tool within 2mm of the jaws, hopefully. It's a little bit fiddly, this, isn't it? It's difficult to get in there. So let's see if I can see what I'm doing. So can't quite get my head in there to see what on earth I'm doing. So I know what we'll do. We'll for our measuring, what we'll do is we'll use our little tire gauge depth indicator. So what we'll do is we'll pop that on. Let me see if I can get it so you can see that a bit better. All right, hopefully you can see that. So what we're going to do now then, plan B Mark 5, we'll just touch off, and then we'll zero our little poor man's DRO, and then all we got to do is wind it back to -2mm. There you go. See, I knew there was a way. I was going to ask you guys to leave something in the comments, but that would just take too long. By the time you've done that, I'll have finished. So you can still leave something in the comments if you can think of a much more foolproof way of doing it, and I've just proven there. So anyway, that is 2mm. That's all I want is a line now. So I'm just going to fire it up, and then we'll just plunge in and scribe a little line, and that should be 2mm from the face of the jaws. Okay, nice. Okay, so now we take this down to 6.35mm up to our mark. Okay, let's see what we have. Just under 6.3, that's fine. And the depth here, 2.75 on the thickness there, 2.74. So we've got a bit to come off this end here, but we can do that in a little while. So what we'll do is we'll set up with the next tool, which will be back to the parting tool. We'll use that just to undercut things. And I believe we're still square from last time on that. Let's have a look. Near enough. And I'm just going to sort of check the height on that as well. So see what diameter we've got here. 6.27. .3 I'm reading if I look at it that way. So if we want the cutter to be 3.15 mil below the surface there, below the top of the job, just going to check this roughly like this just to get a sanity check. 3.15 we want, and we've got 2.84, so the tool needs to go a little lower, but I don't think the tool will actually go any lower in the tool holder. I think that's as low as it'll go. So we'll see if we can draw it back out a little bit, because that'll lower it down, because it angles upwards. So we can lower it by bringing it out backwards a bit. And we don't need too much sticking out anyway. So let's try that and see where that gets us. Well, 3.14 that's saying. So according to that, we're like 0.01 of a mil out on our height. So that's going to be close enough for what we want to do here. All right, so what we're going to do, we need to go 7 mil in from the end, because the thread part is 7 mil long. So we'll just mark this up a bit. And we'll come in 7 mil-ish. 7 approximeters. There we go. And that'll give us the end face for the thread. That'll do. And again, I'm just going to lock the lead screw just to firm things up a bit. That moved back a little there. Let me just recheck that. Yeah, we want to come forward a tiny bit. Okay, and we want to take this down to 4.8 mil diameter. So we'll slow the speed down a little bit and just... see what we've got. Back that off a little bit more. So 5.22, I'm getting there. Okay, that should have gone in by 0.4, hopefully. So let's see where we ended up. 4.88. So we can go in just a tiny little bit more. That's probably enough, but we'll go a little bit more and then we'll just sort of copy that diameter across the whole shaft there. that's that sort of free-handed. So we'll see where we are and then go from there. 5.11 that end, and then the end we started working on is 4.84. So if we come to this end, touch off, we should be able to just move along to this side, and that'll do. And I'll just check our depth of our flange there, because we've just taken that down a little bit more. And we've got 2.56, 2.54. So we need to take a little bit of thickness just off there as well. So we'll do that first. We must be getting close now. 1.97, perfect-ish. Right, so we'll just touch off there and see if we can feed along, level out that shoulder. Okay, let's give that a quick check. So I've got 4.9 there and 4.87 at the other end. I'm going to take a little bit more. I want to get it down just a little bit closer. Okay, how's that looking? 4.77 and 4.8. 4.85, that's fine. And so I'll just put a threading tool on. I'm just going to cut a little chamfer either end of that for the thread. And then we can cut the thread. So the next thing to do is to get everything set up for cutting the thread. We've already got the gearbox set up for the correct pitch that we need. And I just need to rejig all of this. So what I'll do, let me do that, and then I'll bring you back in when that's done. We're all ready to cut some threads now. Let me just walk you over what we've got set up here quickly, and then we can get on and we can start cutting the thread. So over here, you can see I've got what's known as a mandrel handle fitted into the back of the chuck spindle. And that means I'm going to be basically hand cranking the lathe. I've got the lathe turned off. I'll turn the speed off as well, but it's actually switched off. So we don't want any power on when we're using this, obviously. But the mandrel handle just lets me actually hand crank the lathe backwards and forwards. And for cutting a small thread like this, it's just a nice, easy way of doing things rather than power feeding. Okay, the setup we've got here. Now, I'm just going to go through this very briefly. If you want an in-depth talk about the way this is all set up, then check out my other video on making a homemade brass pressure washer adapter. And in that one, we cut some threads, and I go into a lot more detail as to why I'm using this particular setup. But basically what we've got is we've got the compound slide kicked over at 29 degrees, and we're going to be using that just to advance the cutter into the thread. This basically sets our depth of cut. The cross slide is merely a 0, and that is set on this dial gauge over here, which you can see is on 0. So this means that basically what we do is we feed the cutter into the work, we take a cut along this way, and then when we're done, we need to leave the lathe in gear, so it's always engaged. And then we'll basically retract the cutter with the cross slide, wind it back out again the other way by reversing the lathe. Then we can bring the cross slide back to our 0 point, knowing that we're where we left off, wind in a little bit more on the compound slide, take another cut. So that's what we're going to be doing, and let's make a start. So first of all, I'm just going to come across here and make a bit of a spring pass. And I've already put some Sharpie on the thread. And what I'm going to do, I'm just going to grab a thread gauge quickly. And what I'm going to do is just verify that we're on a 1.25 pitch. So let's have a look. Yeah, it looks pretty good. All right, so we can just wind back because we haven't actually really taken a cut yet. So I'll just wind back out from there, and then we can advance the compound slide a little bit, and then we'll take our first cut. Okay, that's the first pass. So we'll wind the tool out a little bit, and you'll see the dial gauge rewind, and we can bring the cutter the other way. We have to keep the lathe in gear all the time we're doing this. I don't have a thread dial indicator, otherwise I could disengage the half nuts and just wind it out with the feed, but we don't have that. So that's the cutter back out of the way. We then bring the tool back into our 0 point. That'll do. Dial in a little bit more depth, take another cut. And from there, just rinse and repeat. Okay, at this point, I'm going to test and see how close we are. What I've got is I've got a camera mount here that's got a brass insert, and we're just going to judge this by whether it fits or not. So we'll just wind this out of the way. It's a bit tedious that we've actually got to wind this all the way out. If we were actually power feeding it, it'd be a lot quicker, but it doesn't take too long. So we'll just get this far enough out, and then we'll see if it'll actually fit yet. We'll see whether we've got whether we've got a bit more distance to go. No, that's not going to go yet, so more work to do. Go back to our 0 points, advance in a little bit further. Retract it, wind back the other way, back to the 0, take it a little bit more. looking pretty good so far. So we'll give it another little test. No, it doesn't quite want to go yet. Still a little bit more to come off. Okay, back to our 0 point. What I'm going to do, actually, I'm just going to take the tool out carefully. I don't like to reset the tool partway through a cut, but it'll save me having to wind it all out too far to fit this part. Let's see if really close it's a bit fitting. Yeah, it's almost on there now. It's in fact, I'm wondering if that's actually bottomed out in here. No, I don't think it has. Yeah, that's fitting on there quite nicely. All right, looks like we're done. Okay, well, I'm going to call that done. So what I'm going to do, I'm just going to remove the handle from the back because we don't need that anymore. And I need to power the lathe back up because I just want to run a file over the crests on the thread just to clean it up a little bit. So have a look, just very gently on there. Okay, that's that done. Let's take that out the chuck and have a quick look. And there we go, that's the finished part. I say finished, there is one more thing we need to do, which is to get it in the vise, and we're going to file a little flat on here, and this is basically where the knob is going to push onto. So the knob will push onto there, and we'll have a little flat to help locate it on there, and that will sit in there, kind of like that. All right, let's get over to the vise. All right, so we need to cut a flat on here about halfway down and about 2 mil from the end. Again, it's not really critical how that ends up. I'm kind of hoping I can just hold it in the vise well enough like this. It's always a little bit tricky with stuff like this. I could actually hold this in the lathe to while I file it, but that does mean then gripping onto the thread, and I don't want to risk marring up the thread. So we'll see how we get on. So let's see how we get on with this. What I really want to do is get this left-hand edge kind of established, and then I can use the safety edge of the file with no teeth on it, and it shouldn't go too much further into that edge then. So I'm just going to get that established to begin with, like that. And let me just check how far I've gone in there. So we're looking at about 2 mil. That's cool, that's just about slightly under that. And then we can switch over the safety edge against there, and it shouldn't eat too much into there. So I'm still going to guide it a little bit with my fingers while we sort of start to get the depth down. And I'm just filing gently now. I'm not really pushing very hard. I don't want to pop this out of the vise for a start, but just keeping it level and keeping an eye on the shape that I'm making. I want to parallel sides on this flat, and I don't want it tapered up or down. So just creeping on where we want to go. Be careful not to kind of come over this edge too much. So starting with the safety edge at this end and then just working that way. And of course, if you've got a milling machine, you could always set this up and mill a flat on there, but I find that a lot of the time it's just as quick just to grab a file and do it by hand. So plus you get a little bit of exercise doing it the old school way. Plus I don't actually have a milling machine, so that's another reason why I'm doing it this way. So I'm staying away from that shoulder on the left there. You see that's just getting a bit curved. I can square that up in a minute. I just don't really want to go over it. That's the main thing here. So the trick really with this is just keeping the file flat and level. And you can do it partly by feel, partly by eye. You can sort of see where this cut's taking you. You can see that this looks fairly nice and square on here. Parallel sides and not tilted either way. So that's what we want. Yeah, it's always nice working with brass, to be honest. Steel is a lot more hard work when you're filing it. Brass is a very pleasant material to work with, really. So I'm just going to go to the non-safety edge and see if I can bring this edge back in a little bit this way. And my guideline really, I suppose, is getting level with the jaws of the vise. That should be the halfway point on the flat. That's as deep as it should need to go. Just squaring up this face a little bit here, using the safety edge on the job because this won't cut. Then I can just use it to come this way a little bit. We can be a little bit more deliberate now. Now we've really established that shoulder. We can be a little bit more purposeful in our work here. And we're almost down to depth. And what we'll do in a moment, when I've got it down as far as I can, we'll check the thickness, and it should come out at about 2.5 mil if we're halfway. Like I said, it's not critical, this dimension, because we're just going to be squishing it into this in a moment. So as long as it squishes in and holds, that's good enough. A little bit more to come down. Okay, let's see how far we got with that. Looks like it might not be too bad. So 3.01 there and 3.16 at the other end. So we're about 0.5 mil over. So I'm just going to see if I can raise it up a tiny little bit, which will be tricky because it's going to be trying to grip on the bottom of the curve there. So just gently hold it and see if we can just sneak a little bit more off the thickness there without it popping out of the vise. Just go very gently. So 2.7 at that end, 2.9. So we've got a slight taper towards this end. So let's see if we can take a little bit more. I'm just going to go to a smaller file, I think, for that. And what I'm going to do is just put a bit of Sharpie on here because I want to see if I can get rid of that taper a little bit. So this will let me see where I'm filing. So I want to file this end a little bit heavier. So I can see now that I'm at sort of an angle where I'm only taking it off this one end. Okay, so we're 2.7 at that end and 2.77 at the other end. So we're 0.2 mil over. I definitely want to take this down a little bit more because I don't want to split the plastic when I force this in there. So it's getting quite hard to hold on to now. So going back to the bigger file, I think that was doing a better job. All right, so 2.4 at this end and 2.6 at the inner end. So I'm going to take a little bit more off that inner end. Let's just mark it with some dye of sorts. I just want to take a bit off the inside now, not the outside. So it's getting quite tricky to hold because we're smack on halfway. We're just looking to take it off that inner edge a little bit. And then work down to flat from there. All right, let's see where we are. So we're 2.4, 2.39 that end, 2.44, so 5/100ths of a mil. That's not too bad, not too shabby. So we'll put this into the knob in a moment. So what we'll do, we'll just deburr it ever so slightly. Not that it really matters too much. If anything, burrs might help it grip, you never know. But we'll just take some of the little sharp edges off. And then, all things being equal, this should press fit into here. And then we've got our finished knob. So let's see how that goes. Okay, and there we go. That's the the finished knob, all ready to go. So all we got to do now is go back over to the clamp, which is here, and we need to cut a thread in here, quarter 20 UNC thread through this. This can go in, and then we'll put an M6 thread through here, and then we're getting close to finished. Well, that's the metalwork all done, and I did promise you before that you'd be excused from metalwork if you weren't into that kind of thing. So what you can do is, rather than having to make your own one of these, you could actually just go to somewhere like eBay or possibly Amazon, and you can buy one ready-made. So you can buy these ready-made aluminium knobs, or you can buy them made of all different materials. You can buy them different thread sizes. So if you want to replace one of these, you could basically buy one that's, let's have a look how long this thread is on here. So if you got one that was a quarter UNC by, what's that, 14 mil, so about ½ inch, maybe slightly over. So you could get one of these quarter UNC by ½ inch or so, a little thumb screw, and then you could pop that through. What you would need to do though, with this, we've got the luxury of having this little undercut here, which means that this can become a captive screw. You'll see that in a moment when we actually put it in there. But what you would need to do if you bought one of these and it was threaded all the way along is you'd have to basically drill this hole out to be ½ inch, and this would just fall out when you don't have a camera on there. That's the only downside of doing it that way. For the other side, what I'm going to do with this, I happen to have an M6 by 20 panhead screw kicking around in my stash. It just doesn't have to be a panhead, it can be anything, but I'm going to use this on this end, so I'm going to tap this M6. But again, you could actually use an imperial thread on that if you wanted. You could probably use quarter UNC on that and just drill and tap this hole accordingly. All right, so let's tap some holes. So I've got a quarter 20 UNC tap, and first of all I'm just going to tap this hole here. So when we're tapping plastic, you want to go very carefully with it. If believe it or not, if you tap it too fast, you can actually melt the plastic with the heat it generates. It generates quite a lot of heat tapping holes. So you turn it a little bit of the way, rotate it anti-clockwise just to break the burr, and just take your time, ease it in. Then once it gets going, keep it nice and square, both directions. And we just give it a little turn, back it off, give it a turn, back it off. And then once it starts to get through, then you're just basically cleaning the thread out at that point. So we're all the way through now. Okay. So that's that one done. And then we can fit the knob. And you'll see what I mean about the captive screw. So we take our knob. This then can screw through here and get it started. There we go. And we put that all the way through, and it'll get so far through, then it'll fall through like that. So you can see it it's captive, it won't move. And with that, we can then fix our camera adapter to that. So if we then do this, we can fix that on there like so. And there you go. All right, so let's tap the M6 hole and put the M6 bolt in there. So I'll just change over to an M6 tap, which I happen to have. Just eyeball that to make sure it's the right one. Yeah, that looks pretty good. All right, so now we can tap out the M6 hole. Again, just take it steady. It's very easy to split the plastic if you give it too much yahoo, and we don't want to do that. And you can see here we've actually got, there is a weak spot in the design here. You can see because of the grain of the plastic, the grain runs this way. So this is a weak area here that could split open very easily. And it probably will. When you clamp it up, it's quite likely it will split. But if it does, a little bit of CA glue, a little bit of super glue on there, will glue it quite nicely. And again, just take it slowly because it's very easy to overheat the plastic, especially if you're if you made this out of PLA. PLA will overheat very quickly. This is ASAX, so this is a bit more tolerant to temperature changes, but even so, just go steady with it until you're through, and then you can run it through, and that should do it. And then we should be able to fix our screw in. Like so, and there's our finished clamp, ready to clamp to a boom arm and to try it with a camera. So let's give it a go. All right, so we've got the camera adapter made now, so let's give it a go on the boom arm and see if it works. So what we'll do is we'll pop this on the end here, and then do up the screw, and that should clamp it on there, hopefully. If my calculations are correct. So we don't want to do this too tight because we don't want to split the plastic. So what we could do now that we've got a camera bracket on here, is you could fix any kind of camera on there you want. Like this is one of these little mobile phone camera holders. So if you wanted to stick your mobile phone on the end of this, if you trusted your engineering that much that you trust it with the life of your mobile phone, so you could get one of these on there, and you could screw that on, and then you could sort of push this to be wherever you want. You could locate that wherever, and that would work quite nicely. But what I've got is one of these that I prepared earlier. This is, I think I showed you something similar in the first episode of this, in part 1. This is a little GoPro adapter. I like using GoPro Hero 4s. They're very cost-effective little cameras that are easy to get into places. All you do is you get this little adapter here, and you pop your GoPro in, sort of like that, and there you are. Now this has got 2 quarter UNC threads in it, so there's one at the bottom, so you can screw it on like that, and then there's one in the back, so you could screw it on like that if you wanted to, pointing upwards, where you could have it pointing downwards. So let's say for example, you wanted to film something on the desk, you wanted to do something, you know, like a hand cam, you want to show something that you're making. So what you could do is you could actually flip this the other way up. So if I do that, if I put it this way up, then what I can do is I can fit the camera under here like this, and I can rotate it to whatever angle I fancy. And then with the camera, I can then adjust the height. So I can, on the boom arm, I could bring it in so it's quite low, or I could bring it up a bit higher, or I can move it further in or further out, and so on, things like that. But what you could also do is you could actually just rotate it around like this and level it up. And again, you've got just a adapter that you can just put wherever you want then, really, and angle it however. So yeah, there you go. That's the camera mount. Now, all the 3D files for this, I'll put them up on the Patreon. So if you want to actually download these, you can. And also what I'll do is I'll put up the 3D model and probably the fusion design for the GoPro mount as well, in case you wanted one of those if you have to use GoPro Hero 4s. So in this series, what I really wanted to achieve was to not just really show you making a camera mount specifically, but just to sort of share my own design process, how I look at a problem, how I work out what I want to do, come up with some ideas, design it, and then actually make it. So, and I hope you found that useful to follow along with that. So if you've got any questions, leave them in the comments below. I'll put some links in the description to the various things we've talked about, and also to the Patreon. And I'll probably put up a blog page as well on the website with a bit more info as well. So yeah, well, I hope you found that interesting. And as always, until next time, thanks for watching.